In the catalogs of orbital debris, it was listed under a dry, unremarkable number. No name. No purpose. No mission end date. Just another line in a data array containing hundreds of thousands of objects that had long since lost contact with Earth. And yet, it was precisely this line that caused errors. Every time the automated system for updating orbital parameters recalculated trajectories, it returned contradictory results. The satellite should have been descending. Atmospheric drag, solar radiation pressure, gravitational perturbations, everything pointed to the same conclusion. An object at that altitude, with that mass, should have lost stability many years ago. Its orbit should have degraded, stretched, and then ended in a fiery trace through the upper layers of the atmosphere. But it did not fall. It remained on an almost perfectly stable orbit, as if someone were invisibly and continuously making corrections. At the same time, the satellite had no functioning propulsion systems, at least according to official data. Its power system was considered completely dead. The last confirmed signal had been recorded decades earlier and classified as background noise. The tracking system tried to ignore the anomaly. Algorithms smoothed the data, attributed discrepancies to measurement errors, space weather, telemetry faults. But the satellite stubbornly remained where it was not supposed to be. That was what drew human attention. At first, one person's. Orbital dynamics analyst Marcus Hale was working the night shift. His job was not to look for mysteries, but to eliminate inconsistencies. He was accustomed to the fact that space rarely behaves perfectly, and that any calculation requires corrections. But that night, the corrections refused to converge. He checked the model 3 times. Then he replaced the input data. Then he used an alternative algorithm. Then another. The result remained the same. The satellite was not losing altitude. It was as if it were tethered to an invisible point in space, not to Earth, not to the stars, but to the orbit itself, as though the orbit were not a consequence of physics, but a condition of its existence. Hale pulled up the archival records. The launch year had been erased. Literally, the database contained a service symbol used for classified programs instead of a date. The mission name was absent. Manufacturer not listed. Country of origin undefined. That does not happen. Even the most secretive spacecraft leave traces, contracts, production codes, serial numbers. Here, there was nothing. The satellite existed, but it had no past. He zoomed in on the visualization. The model showed an object of irregular shape, not a classic cylinder, not a panel-based construction. The contours were blurred, as if the system could not determine its exact geometry. When he attempted a three-dimensional reconstruction, the software issued a warning about insufficient data, even though the object was being observed by dozens of radars. Hale made a note and sent a request to the Deep Archive. The response arrived a few minutes later and contained a single line. Access restricted. Clearance level exceeded. That was strange. His clearance allowed him to work with Cold War-era materials, experimental craft, with programs that officially never existed. But this satellite was closed even to him. The next day, he showed the data to the shift supervisor. The man stared at the screen for too long, then silently closed the file and advised him to forget the discovery. Not harshly, not as an order, more like someone who knows that some questions are better left unasked. But the process had already begun. A few weeks later, the object surfaced in the reports of another tracking center. There, it was noticed because of inconsistencies in collision forecasts. The satellite turned out to be a blind spot for calculations. The system could not accurately predict where it would be after a given time interval, even though its orbit appeared stable. This contradiction attracted the attention of a commission. The commission was not public. It consisted of people whose names rarely appeared in open sources, former engineers from black programs, military analysts, specialists in anomalous phenomena whose very existence was officially denied. They did not ask, "What is it?" They asked something else. "Why is it still there?" The calculations showed the impossible. If one accepted the known parameters, the satellite should have entered the atmosphere at least 7 times over the past 20 years, under different models, under different conditions. But each time, in retrospect, its orbit appeared to have been corrected after the fact, as if the past itself were adjusting to the fact of its existence. An attempt to determine the age of the structure produced an even more disturbing result. The materials of the hull, judging by the reflected signal, did not correspond to the standards of its presumed era. They looked too modern for an old spacecraft and too primitive for a new one, as if the satellite had been assembled outside of any temporal context. Someone on the commission uttered a phrase that never made it into the record. "It doesn't fall because it doesn't consider it necessary." At first, the thought seemed metaphorical. But the more data came in, the less it sounded like a joke. The satellite emitted no signals. It did not respond to attempts at active probing. It did not answer. But it accounted for things. It accounted for the motion of Earth, the Sun, the Moon. It accounted for perturbations. It accounted for the observer. And most importantly, it continued to remain where it was not supposed to be. As if its presence in orbit were not an error, but a condition. As if falling were an unacceptable state for it. And if it ever does fall, it will not mean system failure, but the completion of a task. The commission began with the most obvious step, rechecking the fundamental laws on which all orbital mechanics were built. Not in theory, but in practice. They took data from the past 40 years, stripped away everything extraneous, removed automated corrections, and forced the systems to calculate blind, the way they had in the early decades of the space age. The result was disturbingly stable. In every model, the satellite should have been losing altitude. Not abruptly, not catastrophically, but slowly and relentlessly, orbit by orbit, kilometer by kilometer. Atmospheric drag at its altitude was weak, but constant. Even microscopic decelerating forces, over decades, should have done their work. But in reality, this did not happen. When analysts overlaid real data onto the predicted trajectories, they saw something strange. Every descent curve appeared to be cut off. Not completed, not smoothly diverted, cut off, as if the object itself suddenly vanished from the calculations. And then it reappeared, already back on a stable orbit, as if nothing had happened. It looked as though the satellite was dropping out of the system of equations. Engineering teams tried to explain this using known effects. Hypotheses were proposed: unknown gas emissions, hidden propellant reserves, microthrusters running on residual energy. But each version required assumptions that contradicted the data. Corrective systems require energy. Energy requires a source. There was no source. Moreover, the satellite's thermal profile remained almost unchanged. It did not heat up or cool down the way a dead object should. Its temperature seemed to be held within a narrow range, regardless of whether it was in Earth's shadow or under direct sunlight. One of the specialists noticed another anomaly. When attempting to predict the orbit more than a few days ahead, accuracy dropped sharply. The system began issuing warnings atypical for such calculations. The wording was strange, as if written by something other than a human. Insufficient conditions for a stable forecast. Object behavior cannot be extrapolated. Model not applicable. These messages did not correspond to any known error category. That was when the decision was made to do something previously avoided: consult the old archives manually. Not digital copies, physical media. Paper reports, magnetic tapes, film reels stored in underground vaults, never connected to modern networks. That was where the first match was found. A report from the late 1970s mentioned an object described in almost the same terms. No name. No mission. Marked, not subject to standard accounting. The engineers of that era had encountered the same issue. The satellite did not behave like a passive object. One sentence in the document was underlined in pencil. The orbit is maintained without visible cause. Beside it was a note in a different handwriting. There is a cause. We simply do not know what to call it. The report ended there. The following pages were missing. The inventory listed them as removed. The deeper the commission dug, the clearer the pattern became. Every 10 to 12 years, the satellite resurfaced. Always in different countries. Always in different institutions. And always with the same ending: documents disappearing, leadership changes, abrupt termination of research. In one case, an engineer died in a car accident. In another, an entire team was disbanded due to reorganization. In a third, the data simply stopped updating, as if the object had fallen out of view. But the satellite remained. Its orbit aligned almost perfectly with a plane passing through several key points of gravitational balance. It was a strange position, not optimal in terms of energy efficiency, yet remarkably stable. As if someone had chosen it deliberately. A systems dynamics analyst brought in by the Commission proposed an unconventional model. He did not claim the satellite was maneuvering. He suggested that the satellite was altering the conditions under which its motion was calculated. If the object somehow influenced local parameters of space, even minimally, then all equations became inapplicable. Not because they were wrong, but because their domain of validity had been violated. The idea was too radical. But it explained a great deal. For example, why the satellite's behavior became less predictable under active observation. Why radars recorded discrepancies. Why models that incorporated more data performed worse, not better. As if the very act of observation were a variable. The Commission attempted a controlled experiment. Several ground stations simultaneously stopped tracking the object. No queries. No measurements. The satellite was left alone for several days. During that period, its orbit became perfect. No noise. No deviations. No discrepancies between models. All calculations converged with textbook precision, as if the object were an ideal reference example. When observation resumed, the anomalies returned. This result did not make it into the official report. It was dismissed as a methodological error. But within the Commission, it became clear the satellite was not merely in orbit. It was, in some way, reacting to attempts to understand it. And then a question arose that no one had dared to voice before. What if it does not fall not because forces are holding it up, but because falling is not a state defined for it? What if the satellite is not an object subject to an orbit, but a boundary where familiar laws end? Toward the end of the session, one of the Commission members noticed another detail, the most unsettling one. All models in which the satellite eventually fell ended the same way. Not with destruction. Not with incineration. But with the disappearance of data beyond a certain point. As if the calculations could not see past the moment when the satellite was supposed to enter the atmosphere. As if nothing existed beyond that point. And if that was the case, then the question, "Why hasn't it fallen yet?" was formulated incorrectly. The correct question was different. What will happen if it does fall? The archive was located below the groundwater level. There were no signs pointing to it, and it did not appear on any official floor plan of the building. Gaining access required not so much authorization as knowledge, an understanding of what exactly to look for, and whom to ask the right question. The Commission obtained access unofficially. Formally, the archive was listed as dismantled. Its collection, declassified and redistributed among other repositories. In practice, however, it continued to exist as an isolated space containing materials that fit into no classification system. There was no name on the metal door. Only a stamp, faded with age. Destroy after review. That stamp appeared on dozens of folders inside. The documents belonged to different eras. The earliest dated back to the late 1950s, when humanity was only beginning to learn how to keep objects in orbit. The latest came from the early 2000s, already in the digital age. Yet between them there was a strange continuity, as if all the materials were fragments of a single unfinished report stretched across decades. At the center of everything was always the same thing: the nameless satellite. In the earliest documents it was called an anomalous object. Later, an orbital phenomenon. One report used the term stationary observer, crossed out and replaced with a more neutral designation. None of the reports contained any description of a launch. That was the strangest part. Any artificial satellite leaves behind dozens of documents, trajectory calculations, launch protocols, personnel lists, weather conditions, telemetry. Here, there was nothing. The satellite seemed to have appeared directly in orbit, without a prehistory. One early report mentioned a hypothesis of external intervention, but it was marked as unacceptable and struck through. Beside it was the signature of a person who later vanished from all databases. The further the commission progressed, the more disturbing the tone of the documents became. In the 1970s, researchers first noticed that the satellite affected the failure statistics of other spacecraft. Nothing catastrophic, minor deviations, odd synchronization errors, timing mismatches. Always within acceptable limits. But when these incidents were mapped onto orbital charts, they formed a narrow band coinciding with the trajectory of the anomalous object. In the 1980s, the first records of temporal inconsistencies appeared. Satellites passing nearby registered microscopic discrepancies in their internal clocks. Milliseconds, then microseconds. Too small to trigger alarms, but too large to ignore. One engineer wrote in a service memo, "The object is not merely located in space. It may be anchored in time." The phrase was underlined in red and marked as an unacceptable interpretation. By the 1990s, the documentation became fragmented. Many pages were missing. Some had been replaced with blank sheets stamped removed. But even what remained was enough to see a pattern. Interest in the satellite would intensify, then abruptly vanish. Always for external reasons, shifts in priorities, budget cuts, restructuring, and always at exactly the right moment. In one folder, the commission found a report unlike the others. It was written not in dry technical language, but in an almost personal tone. The author, a leading specialist in navigation systems, allowed himself doubts and questions. He wrote that the satellite behaved like a reference point independent of gravitational fluctuations. That all measurements in its vicinity became less reliable, as if space itself were losing rigidity. And that attempts to determine its precise position were always delayed. The data arrived with a minimal but consistent lag, as though the object were being recorded not in the present moment, but slightly earlier or later. At the end of the report was a handwritten note. "If it ever leaves orbit, it will mean that it is no longer needed. The question is, by whom?" This was the last report signed by the author. 6 months later, he resigned. A year after that, his name disappeared from employee lists. There was no public information about him. The commission noticed a pattern. People who went too far in their interpretations ceased to exist in history. They did not necessarily die. They simply vanished from the professional field, as if their contributions had never existed. One of the most recent folders contained a transcript of a meeting. The audio recording had not survived, only the text, and even that was incomplete. But the fragments alone were unsettling. "The object performs a function. If we remove it now, the consequences cannot be modeled. We don't know what it is holding." The last phrase was repeated several times, as if the speaker were insisting on its importance. For the first time, the commission confronted a thought they had previously avoided. The satellite might not be merely an observer or an anomaly. It might be an element of containment. Not a weapon in the conventional sense. Not a defense. But something that holds the system in an acceptable state. When the documents had been reviewed, a question arose: why did the archive still exist? Why had it not been completely destroyed, if the materials were so dangerous? The answer was found in the last box. Inside lay a report marked "Final." It was dated, but the date had been blacked out. The text stated that the object could not be eliminated, could not be intercepted, and could not be ignored. The only acceptable strategy was observation without intervention. At the bottom of the page was a handwritten note: "Preserve the archive. Destruction of information increases risk." Risk of what was not specified. When the commission left the archive, one of its members noticed that the access control system recorded their time inside as 20 minutes longer than their watches showed. No one commented on it. The next day, one of the analysts who had worked with the archival data failed to make contact. At first, his absence was attributed to a communications failure. Then, to personal reasons. A week later, it was discovered that his account had never existed. As if he had been part of the archive itself. The decision was never made officially. It was not recorded in the minutes, not approved by signatures, not placed on any agenda. It emerged as an inevitability, a chain of small agreements, half hints, and silent nods exchanged between people who understood that observation was no longer enough. If the satellite reacts to attention, then it can be interacted with. That was the logic. Simple and dangerous. Formally, the experiment was called a test of communication channel stability under conditions of orbital anomalies. In reality, it was the first attempt to address the object directly. Not with a telemetry request, not with a standard protocol, but with an active impulse aimed precisely at the moment of closest approach. No messages. No codes. Only a signal. Compressed, powerful, synchronized in time to nanosecond precision. The Commission insisted that the experiment be conducted simultaneously from multiple stations. Different frequencies, different modulation methods, different directions. If the satellite truly influenced observational conditions, discrepancies should appear. Preparation took weeks. Everything was checked: equipment, backup systems, power sources. No one wanted the result to be dismissed as a technical failure. At the moment of transmission, the control center was silent. Not tense, focused. People stared at screens where scrolling lines of code gave way to graphs and time scales. The signal was sent. And almost immediately, something went wrong. Nothing visible happened. No alarms flashed, no sirens sounded. Systems continued to operate, data kept flowing, graphs updated. Yet several operators experienced the same sensation. As if the center had become quieter. Not physically. Informationally. Data streams seemed to slow down. Not in transmission speed, but in relevance. Some parameters stopped updating, not as in a failure. They simply froze at their last values, as if they had decided there was no need to continue. A few seconds later, the satellite passed through its calculated position. At that moment, the time synchronization systems failed. Atomic clocks located in different buildings, and even in different cities, began to diverge. Microseconds, then milliseconds. It was enough to trigger a cascade of errors. Some processes halted, others tried to compensate for the discrepancy, others entered protective mode. The experiment was terminated immediately. Transmission stopped, channels shut down, stations switched to passive mode. Only then did the data arrive. There was no response. No reflection, no return signal, no anomalous radiation. The satellite remained as silent as before. But its orbit had changed. Slightly. So little that without targeted analysis it would have been dismissed as noise. But to those who knew its previous parameters, the deviation was obvious. The satellite had shifted, not in altitude, not in inclination, but in phase. It was slightly ahead of where it should have been. As if it had arrived at that point early. The Commission split. Some argued it was coincidence, a result of synchronization errors. Others saw it as confirmation of the most dangerous hypothesis. The object was not merely reacting, it was anticipating. Over the following days, strange things began to happen. No catastrophes. No overt anomalies. Only small details that meant nothing individually, but together formed an unsettling picture. Communication satellites registered brief synchronization losses. Navigation systems issued warnings about being unable to refine position with previous accuracy. In one case, an unmanned vehicle performed an orbital correction a fraction of a second before the command was issued. All events occurred within acceptable tolerances. But all of them, near the orbit of the anomalous satellite. One of the analysts noticed another detail. After the experiment, some of the data related to its preparation had disappeared. Not all of it. Only the earliest versions of the calculations. As if the system, knew exactly which files were connected to the contact attempt and had carefully removed them. This could not be proven, but it could not be explained any other way either. A week later, one of the operators present during the signal transmission filed a report describing strange sensations. He claimed that at the moment of the experiment he experienced a feeling as if he had remembered something he had never known. Not an image, not a sound, but an understanding, brief and frighteningly clear. He could not put it into words. Medical evaluation found no abnormalities. The report was closed. But he was not the only one. 2 other staff members reported similar experiences. Each described it differently, but all shared the same core impression. For a brief moment, they felt they were not inside the control center, but being observed. Not by eyes. Not by instruments. By something else. The commission reconvened behind closed doors. The question no longer sounded like, "What is this satellite?" It had become something else. "Do we have the right to continue?" One of the commission members proposed a radical step, a physical approach. Launching a small inspection vehicle to pass nearby and transmit images. The proposal was met with silence. Because everyone understood, the next step would be irreversible. If the satellite truly was part of a system beyond familiar physics, then approaching it might alter not only its state, but their own. That same evening, the automated tracking system recorded an event it could not classify. For a fraction of a second, the anomalous satellite was not on its orbit. Then it returned, as if it were checking whether anyone would notice. The decision to launch the inspection vehicle was made without a single formal vote. No one wanted to leave a signature under this step, but retreat was no longer possible. After the first attempt at contact, it had become clear. The satellite had registered the attention directed at it. Ignoring it now would no longer be caution, it would be self-deception. The vehicle was designed quickly and with deliberate simplicity. No experimental technologies, no unconventional solutions. It was meant to be as transparent as possible, an object whose behavior would be easy to predict and impossible to confuse with anything else. A small body, high-resolution cameras, a set of sensors, gravitational, magnetic, temporal. Special attention was given to the synchronization system. Independent clocks were installed on board, calibrated to different standards in order to capture any discrepancies. The main requirement was unspoken: the vehicle must not show initiative. It would send no queries, emit no signals, perform no active maneuvers near the satellite. Only passive approach and observation. The launch proceeded without incident. At the early stages, everything appeared routine. The vehicle entered its calculated orbit, executed a series of corrections, and began slowly closing the distance. The anomalous satellite remained in place, showing no deviations. The commission observed. When the distance shrank to a few kilometers, the first oddities appeared. The vehicle's cameras began transmitting images with delays, not constant, but variable. At times the feed was nearly real-time. At others it lagged by fractions of a second. These jumps did not correlate with communication load or the vehicle's position. Then came problems with focus. The auto-correction system attempted to sharpen the image, but the satellite's contours remained unstable. Its shape seemed to change depending on the viewing angle. In one frame it resembled an elongated cylinder with panels. In another, an asymmetric structure lacking familiar geometry. Engineers attributed this to optical distortions. But when the vehicle drew even closer, explanations ran out. At a distance of less than a kilometer, the sensors detected local anomalies. Gravity near the satellite was not zero, but it did not correspond to its mass. The magnetic field exhibited a structure unlike anything natural or artificial. And the temporal sensors, for the first time, showed a stable desynchronization between the onboard clocks. The difference was small at first. Microseconds. Then more. The commission halted the approach. The vehicle held position at a safe distance, continuing observation. And then the cameras transmitted something that made the operators fall silent. The satellite's surface was not homogeneous. It consisted of segments, but not mechanically connected ones. There were no seams, bolts, or welds between them. The segments seemed to be held together without any visible cause, forming a whole without physical fastening. At times, barely perceptible gaps appeared between them, only to vanish moments later, as if the structure were adapting to observation. An attempt to generate a thermal map produced an even stranger result. The surface temperature was uniform, too uniform. There were no hot or cold zones characteristic of solar exposure. It seemed as though the satellite maintained its own thermal state independently of external conditions. One of the specialists spoke aloud what the others were thinking silently. "He doesn't age." At that moment, the inspection vehicle registered an event not led by any protocol. The satellite rotated. Not abruptly, not mechanically. It changed orientation smoothly, almost imperceptibly, but enough for the cameras to find themselves pointed, not at Earth, and not at the vehicle. It was oriented away from the planet, toward emptiness. The Commission quickly understood what this meant. All previous assumptions had been built on the idea that the satellite was observing Earth, climate, communications, military targets. But its primary orientation was different. It was looking outward, toward a direction where there was nothing remarkable. No star clusters, no galactic core, no known anomalies. Only the apparent emptiness of interstellar space. And it was precisely there that the sensors recorded the greatest deviations. The inspection vehicle began registering faint but persistent background changes. Not radiation in the usual sense. Rather, the absence of something that should have been there. As if space itself behaved differently in that direction. The Commission ordered additional imaging. At that moment, communication with the vehicle was interrupted. Not completely. Telemetry continued to arrive, but the video feed vanished. Attempts to restore the image failed. The cameras reported that they were functioning normally, but there was nothing for them to transmit. A few seconds later, the temporal sensors lost synchronization entirely. The discrepancy between the clocks reached values that could not be explained by any known effects. And then the vehicle began to drift away. Without a command. Without an impulse. It simply started moving back, slowly, as if it were being gently pushed out of a region where it did not belong. The Commission aborted the mission. The vehicle was placed into safe mode, all active processes shut down. But before it finally exited the proximity zone, one sensor managed to record one last thing. In the direction the satellite was facing, a brief disturbance appeared. Not a flash. Not a signal. A displacement. As if something on the other side had noticed the attention. And if the question once was, "Why hasn't this satellite fallen yet?" it had now changed irrevocably. What exactly is it holding back, and from where? After the incident with the inspection vehicle, a new task emerged within the Commission, to understand how the satellite interacted with temporal parameters. Until then, everyone had assumed it was merely an object in space. It was now clear that it also acted upon time. The first to notice this was an analyst from the Systems Dynamics Group, Dr. Edward Line. He identified a pattern that had previously seemed random. Orbital calculations for nearby objects stopped converging whenever the satellite passed through certain points along its trajectory. This was not ordinary measurement error. Time markers from equipment synchronized with Earth-based atomic clocks showed discrepancies that could not be attributed to communication lag. Each revolution, each pass of the satellite, produced an effect of deceleration or acceleration. At first, fractions of milliseconds. Later, seconds. Every new observation confirmed that its orbit was not merely stable, it ignored the familiar flow of time. To most engineers, this seemed impossible. They worked with equations of motion that always relied on linear time. Any influence of the satellite on time should have been so negligible that it would matter only in theory. But the observations said otherwise. Line proposed a simulation, creating a virtual copy of the satellite and inserting it into a digital model of orbital space without time, where past, present, and future were treated as synchronous. The result was astonishing. The digital satellite adjusted its trajectory so as not to disrupt the overall stability of the entire system. Each time a potential collision with another object approached, the model corrected the satellite's motion retroactively, ensuring that the outcome remained safe. That was when Lyon realized this object was not merely an observer. It did not react to events in the conventional sense. It maintained the system, like a node regulating the flow of time and space around itself. Moreover, any attempt at interference, a signal sent by instruments, observers, or computational systems, led to an immediate correction of the orbit. Not physically, but logically, as if the satellite accounted for the fact that it was being observed and restructured its trajectory to preserve the integrity of a space-time network. According to Lyon, this network extended far beyond Earth's orbit. The satellite's influence was detectable at distances considered negligible for an object of its size. And the closer observation instruments approached, the stronger the anomalies became: clock desynchronization, slow data transmission, even distortion of the video stream. The Commission began using a term that initially sounded metaphorical: an orbit without time. It was not merely a phrase, it described an effect in which the familiar sequence of events ceased to apply. One experiment involved monitoring another satellite passing near the anomalous object. Observers expected ordinary fluctuations, minor velocity changes, small corrections. Instead, they saw that with each pass, the object seemed to roll back the past. Telemetry data arrived with timestamps that contradicted the actual order of events. What had appeared to be equipment error revealed itself as a pattern. Any activity around the anomalous satellite was perceived as interference with its orbital temporal node, and it adjusted events to preserve both its own stability and that of surrounding objects. Edward Lyon formulated a hypothesis that soon shook every member of the Commission. If the satellite maintained the system in this way, then any fall or destruction of the object would be a catastrophic event for the entire orbit. Not for Earth, for an entire structure of which the orbit itself, the surrounding satellites, and the trajectories of space debris were all parts. This realization changed everything. The question, "Why hasn't it fallen yet?" now sounded different. It does not fall not because it can, but because it must not. And if it does fall, it will not mark the end of its mission. It will mark the end of everything it holds in place. At that moment, the Commission realized for the first time that they did not even understand what they were dealing with. The satellite was not watching Earth. It was watching time. After the discovery of the orbit without time, the Commission encountered a new and unexpected phenomenon. The satellite ceased to be merely an object following a trajectory. It became a witness. Not an observer in the conventional sense, but an entity that records events and regulates their course, as if keeping a log of every passage around Earth. The first evidence appeared in the behavior of other satellites. Several spacecraft within the zone of influence of the anomalous object began to display strange, repeating patterns. Systems would freeze, then resynchronize with slight delays, sometimes reporting data about events that had not yet occurred. Edward Lyon described this as lagging behind and racing ahead of time simultaneously. No one on the team could explain how a single system could register the future without violating known physical laws. The second experiment involved an attempt to visually capture the anomalous satellite. Cameras recorded a form that changed from frame to frame, as if the satellite were choosing how it appeared to the observer. At times the outlines were sharp, at others blurred. Panels that appeared solid and three-dimensional would suddenly become transparent. Most disturbing of all, every frame in which the satellite exhibited unusual behavior coincided with moments of observer activity, as though it knew it was being watched. This idea slowly took hold within the Commission. The satellite did not merely exist in space, it responded to attention. Not at the level of electricity or signals, but at the level of information itself. It recorded actions and intentions, adjusting events to preserve its role. The third manifestation was the most unsettling. During one observation session, several staff members working in close proximity to the computation stations experienced a strange sense of déjà vu. Not visual, not auditory, cognitive. As if they already knew the outcome of the experiment before it occurred. Some tried to explain it away as fatigue or psychological pressure. But when all the data were compiled, it became clear their sensations coincided with real changes in the orbits of other satellites, as well as with anomalous signals coming from the object. The satellite was becoming a witness not only to physical processes, but to human perception itself. It seemed to track intentions and respond to them. Moreover, Edward Lyne noticed a pattern. The more attention the satellite received, the more pronounced its activity became. Conversely, when it was left unobserved, the orbit remained stable and all anomalies vanished. For the first time, the Commission seriously considered a disturbing possibility. What if it recorded not only current events, but also those we had not yet carried out? What if the very act of studying it became part of the experiment? These thoughts were unsettling, but the most frightening discovery came when they attempted to correlate all the data collected since the launch of the inspection vehicle. The satellite appeared to have recorded the presence of every member of the Commission, all personnel who had interacted with the archives and data related to the object. And in those records there were no errors, no randomness. Even analysts and engineers who had disappeared appeared as part of the system, fixed by the satellite, yet erased from external observation. The Commission realized that to observe it was to enter its field of record, to become part of what it sustained. And then a question arose, one that had never before been spoken aloud. What does it see? The past, the future, or the very course of events we have not yet committed? The thought was paralyzing. The realization that the object could record human actions and intentions cast doubt on any attempt at control. The satellite was not a silent observer. It was an information node, a point at which all influences on orbit, space, and time around it were registered. And the more they tried to understand its nature, the clearer it became. Any interference would be recorded. Any. And the consequences of such interference could extend far beyond familiar understanding. After months of studying the anomalous satellite, the Commission reached a boundary beyond which only conjecture remained. All previous experiments, calculations, and observations pointed to one conclusion: the object did not merely exist in orbit, it sustained a structure, responded to attention, and recorded events in the past, present, and future. But why? And who launched it? The answer to the first question was found in old archives, buried beneath dozens of layers of secrecy. They contained documents that seemed never meant to be seen. Their authorship was attributed to a classified space program of the late 1960s, a project known under the provisional name Kronos. According to these documents, the satellite was created as an experimental information control node, capable of recording the motion of objects, energy flows, gravity, and temporal shifts. Its mission was not to observe Earth, nor to transmit telemetry, but to keep certain events within the bounds of a stable system. Project Kronos was conceived as a secret effort to develop an orbital time controller, designed to minimize the risk of accidental catastrophes, satellite collisions, equipment failures, and even natural anomalies affecting the planet's orbit. But the satellite's launch took place outside all known protocols. Its designation, launch date, and method of deployment were erased or concealed. The object appeared to have been introduced into the system in such a way that, from the moment of its emergence, it was almost invisible to all conventional tracking mechanisms. The Commission realized that the satellite functioned not as a device, but as an informational entity, a node in a network humanity had never even suspected existed. It recorded events, corrected them, and preserved the integrity of the orbital and temporal system. And then came the first manifestation of an anomaly that no technology could explain. During one experiment, an analyst overseeing observations of the satellite experienced a strange sensation, as though his consciousness had connected to the object's orbit. He perceived not only the current positions of satellites, but also flashes of events that had not yet occurred. Scenes from the past, events no one should have remembered, unfolded with absolute precision. Observers attempted to record this, but cameras, microphones, and telemetry systems detected nothing unusual. What the analyst saw existed only within his mind. After this incident, the Commission realized for the first time that the satellite did not merely record facts, it interacted with the perception of those who studied it. It was capable of turning an observer into part of its own recording system. Moreover, it became clear that any attempt to understand the object's nature generated anomalies around it. Telemetry errors, temporal discrepancies, disappearing records, and even disappearing people, all proved to be side effects of interacting with the node. Then came the final and most terrifying conclusion. The satellite was neither a weapon nor a scientific instrument. It was a guardian, sustaining the system, a witness, recording events, and it did not tolerate interference that might disrupt its order. The Commission faced a dilemma. They could terminate all research and leave the satellite alone. But who could guarantee that its mission would conclude safely without observation? The question remained unanswered. If the satellite were to fall, vanish, or be removed from the system, what would happen to those it held within its orbital and temporal network? No one knew. And that realization hung over every member of the Commission as they left the observation center. The satellite was still in orbit. And it still had not fallen. Because for it, falling would mean the end of what it preserves. And the consequences of such an end, no one dared even to imagine. As the last members of the Commission left the observation center, the sense of unease never left them for a single moment. There were no alarm signals, no sudden flashes on the screens, only silence, and the feeling that reality itself had shifted ever so slightly. The satellite remained in orbit, the very object that should not have existed. Every revolution followed a perfect trajectory. Every moment was a balance between physics, time, and human attention. No analyst had access to the complete data anymore. Some documents that had been readable only days before had vanished without a trace. The names of missing colleagues still sent chills down their spines, yet no one could verify what had happened to them. Edward Lyne, chief analyst for System Dynamics, understood one thing clearly: no one could interfere with the satellite's orbit without becoming part of its system. Attempts at contact, experiments, observation, all of these were not merely actions, but interactions with an entity that records and regulates events on scales far beyond ordinary notions of space and time. He tried to convey this to his colleagues, to explain that the satellite was not machinery, but an information node, one that maintains stability, records actions, and prevents chaos. But many simply refused to accept this reality. To be part of the system meant not only observing, but also feeling the consequences of every movement, every decision. Those who first attempted to approach it with inspection craft never looked at the world the same way again. For them, space and time became mutable quantities, and the familiar laws of physics mere conventions, rules the satellite could adjust. It remained in Earth's orbit, silent and motionless, but attentive. Each new revolution confirmed that it was holding the system together: the sky, orbital debris, satellites, order, chaos, and the very flow of time itself. And that was its mission. Humanity could regard it as a dead object, a forgotten, obsolete satellite. But in truth, it was the guardian of an invisible structure, a node without which an entire network of orbits, events, and possibilities could collapse. And as long as no one interfered directly, it remained in place. Yet the question remained: someday, someone would attempt to remove it from the system. And when that happened, the consequences would be unpredictable. The satellite had still not fallen. It could not fall. For it, falling would mean the end of what it holds together. And as long as it remained there, in orbit, time and order existed only because of it.